Hello, welcome everyone to today's webinar about custom Bluetooth. My name is Sofia. I am a sales manager at Ruptela, and our senior engineer with more than 10 years of experience in Ruptela, Mohammed Yunus, is joining me today. He's going to walk you through custom Bluetooth feature, but before we will start our webinar, let's quickly go through our agenda for today. What are we going to talk about? So, we will start with a little overview of new Ruptela solutions. We have a lot of new features recently, so I would like you to know a little bit more about them. Then we will jump right into custom Bluetooth feature capabilities with real-world business applications. Then we will go to understanding Bluetooth broadcasts and advertisements. Then we will talk a little bit more about accessories itself and feature examples. We will finish our webinar with Q&A sessions, so please feel free to write your questions in the chat during the whole time while we're talking in the webinar, and in the end, we will try to answer all of your questions. So yeah, let's jump right into it. So at Ruptela, our goal is to provide telematics solutions that adapt to your specific business needs. The most recent solution we have is scripting. We have launched scripting. We have recently actually hosted a webinar about it, and maybe some of you joined it as well. So this feature allows you to implement custom logic directly on the device without the need to come back to Ruptela whenever you have a new customer requirement arising. For example, you may have a pharmaceutical company transporting temperature-sensitive goods, and they may want you to, for example, automatically block access to a cargo compartment if the temperature falls below a specific limit. And with the feature of scripting, these types of customer-specific workflows can be implemented directly on the device, enabling automated actions and faster response to business requirements. So next feature is custom Bluetooth, which we're going to be talking about today. And custom Bluetooth, in short, allows you to connect virtually any Bluetooth low energy sensor to your telematics device. This means you can collect data from temperature sensors, fuel sensors, tags, beacons, many other Bluetooth accessories without waiting for dedicated firmware support. We also offer at Ruptela custom CAN functionality. A lot of you may already know about it. So this feature enables you to configure and decode specific CAN bus parameters from vehicles or machinery. If, for example, you're having a problem that standard CAN configuration does not provide the data you need, custom CAN gives you the flexibility to capture and use additional information from specialized vehicles and equipment. We're very proud of this feature. And finally, stay tuned for our new feature, which is going to be released later in this summer, rapid vehicle integration. So basically, this solution will significantly reduce the time required to access vehicle data by eliminating the need for CAN logging during the integration process. And as a result, new vehicle models can be supported much faster, allowing you to deliver solutions to customers with shorter implementation times. Together, all these solutions, we are aiming to give you more flexibility, faster deployment, and greater control over the data they collect, these features. But a part of these features, we have some new hardware released recently or going to be released, actually. So alongside them, the first one is Asset 5. It's our newest tracker. We have released it just last year, and it's actually the smallest 4G tracker device in the market right now. But despite its small size, it offers long battery life. So basically, if you put it to configuration of 2 pings per day, it will last 3 or even more years. And it does have 4G connectivity, as I have mentioned, new generation GNSS module with cell ID fallback, ensuring reliable tracking even in challenging environments. So the other thing we're developing is CAN adapter. It's also being planned to be released in summer 2026. This solution will allow customers to access CAN FD data without replacing their existing hardware. So basically, we're trying to help to protect previous investments while expanding data availability. What is special about this adapter is that it is designed to work across a wide range of vehicles and machinery, including cases where direct CAN access, for example, is difficult or unavailable. And it will also support easy CAN integration. Many of you also may know about this feature, making installations faster and less invasive. And finally, just a little note, one of the advantages of working with Ruptela is that we're giving the direct access to our engineering team. This is not a popular practice, but we believe that it is necessary to give you this personal approach. And whether you have a unique integration challenge or specific customer requirement, our engineers are available to help find the most suitable solution directly. Now that we've covered really quick the latest additions to our portfolio, let's move on to today's main topic, custom Bluetooth. So I'm giving the stage up to Mohammed. And Mohammed, thank you so much. You can continue.
Yeah, thank you so much, Sophia. Thank you. Good morning, everyone, and thank you again for joining today's webinar. My name is Mohammed Yunus. I'm very happy today to present Ruptela's latest development into the custom BLE accessories and our telematics ecosystem. So now let's move to our main topic of today's webinar, which is going to be the custom BLE support. So as you all know, that the BLE sensor market is currently growing extremely fast. So today, there are hundreds of manufacturers producing BLE sensors for applications such as temperature, let's say, sensors, temperature monitoring, fuel level monitoring, worker safety solutions, things like tire pressure monitoring and asset tracking, and many, many other kind of like solutions. The challenge is that, the challenge that we are currently facing in the market, that every manufacturer may use different data and formats. Also different communication protocols. So traditionally, supporting a new BLE sensor required dedicated firmware development from the telematics manufacturer. So this process often resulted in long development cycles, and also we, as a user, we're depending on the firmware release schedule. So let's say you have a new BLE sensor that you want to integrate with our device. You communicate with us, we take your request, and then we go through the development cycle. So it was a little bit hassle for you as a user, and not like time saving for you. It takes maybe months or even sometimes more, depending on the firmware release cycle that we have. So as I said, currently with our custom BLE accessory solution, this changes this approach completely. And instead of waiting for the firmware support, you as a user, can independently configure custom BLE data structures and integrate the new sensor much faster. So you can do these integrations yourself. You can just add them to our configuration, and you will be good to go, on the go instantly, once you have the protocol from the manufacturer. So from the business perspective, this means that you will be getting faster deployments, you will be getting greater flexibility, so you will be like more flexible with the sensor that you choose. Also broader sensor compatibility, so basically you will be able to use any sensor in the market as long as you are able to get the protocol of that sensor. And more future-proof BLE ecosystem, so you were able to customize all your solutions based on the current portfolio of sensors that you are using. So why they matter? The BLE sensors are becoming, as I said, increasingly important in the modern telematics and IoT system because of the fast adaptation to them. One of their biggest advantages is the extremely low power consumption. The power consumption is really low with such sensors. Because of this, BLE sensors can operate for several years on a small batteries without any maintenance. You don't need to go to check, for example, if you install a regular temperature sensor, let's say one wire, Usually it requires you to do the wiring. I mean, it's hassle during the installation. And sometimes, I mean, due to corrosion or something like that, or the environmental conditions, sometimes these type of sensors require regular maintenance. BLAs, I mean, accessories or BLA temperature sensor in this regards, I mean, they really solve this issue. So also because of the long time of the battery, mostly your maintenance would be just you need to go and just change the battery. So talking about BLE, we can say also that the BLE also enables wireless real-time monitoring without additional cabling. As I said, it's not just on the temperature sensors. I mean, it's also on basically any other kind of accessory that you used to do before. I mean, using the cables either through one wire or RS-232 or whichever Bluetooth accessory, accessory that you used to do. So this makes the BLE technology ideal for logistics and fleet management and industrial monitoring, and also the cold chain applications. I mean, refrigerators and this kind of like application that uses this type of accessories, also for asset protection. So the technology can be summarized very simply, that we can say that they can be simple, reliable, and also low in power. So these characteristics, I mean, makes the BLE sensors ideal for scalable telematics deployment. Moving to our next slide, how BLE data reaches you as a user. So to better understand the workflow, so let's look at how BLE data reaches the end user. So the BLE sensor continuously broadcasts, advertisement packets using Bluetooth Low Energy. This is the technology that we're dealing with today. So our tracker from Ruptela, it keeps scanning, the surrounding environment, and listens for the nearby BLE advertisements. And it receives the information, from those beacons or those sensors. So the tracker then takes this data and then forward this to your platform or the cloud platform through the cellular connectivity. And then finally, you as a user receive those data in the forms of reports or historical information or in dashboards, sometimes even alerts, inside of your tracking platform. So in a very simple way, the process is like that. Sensor sends data, tracker collects the data, tracker takes the data, sends it to the platform, and then the platform processes it and displays it to you as the user in a form, as I said, of historical data, reports, or kind of like alerts. So this architecture allows efficient and scalable wireless sensor integration. So now let's look at some practical business applications where BLE accessories are already widely used. One of the most common examples is the cold chain monitoring, where BLE temperature sensors help monitor transported food, pharmaceutical products, and other sensitive goods. So another major use case is also fuel and liquid level monitoring. BLE sensor can help monitor tanks and detect theft from these tanks, and also improve the operational visibility. BLE also are heavily used for asset and equipment tracking, especially for trailers, containers, generators, and other non-powered assets. In addition, safety applications are becoming increasingly important. For example, this includes door status sensors, tire pressure monitoring systems, and also worker safety devices. Um, these examples demonstrate how flexible BLE technology can be across many industries, currently. So what is BLE broadcast or advertisement? So to probably, understand the custom BLE functionality, first of all, we will need to understand the basics of BLE advertisements. So Bluetooth low energy devices, they communicate using the advertisement packets. So they send packets, we call it advertisement packets. These packets are broadcasted using the 2.4 gigahertz frequency band. BLE uses a dedicated advertisement channel that are specially designed to reduce interference with Wi-Fi network, because Wi-Fi and Bluetooth, they both use the same frequency, which is 2.4 gigahertz. So BLE using a dedicated channel to separate it from the rest of the Wi-Fi, surrounding Wi-Fi noise, to avoid this interference. So advertisement communication is usually one-way communication. So its sensor is advertisement. So sensor is sending data to the surrounding receivers. So the sensor keeps continuously broadcasting this information without establishing a permanent connection, just push the data. Traditionally, most the BLE advertisements, they are not encrypted, although with the newer Bluetooth standards, such as Bluetooth Low Energy 5.4, introduces an encrypted advertisement capabilities. This advertisement-based architecture is one of the reasons why BLE devices, they can operate with such low power consumption. So what is BLE broadcast or advertisement packet? Now we're talking about the packet. So now let's look deeper into the structure itself of a BLE advertisement packet. The most important part for us is the payload. This is the most important thing. And one important field for us, we call it the ADVA, which represents the device MAC address. So ADVA is the MAC address of your device or your sensor. The second most important field is ADV data. And this part is the part that contains the actual sensor information, the information that the sensor is broadcasting or sending. This ADV data, section is where the temperature values are contained. Let's say, for example, if the battery information, sensor status, and other, telemetry values, which are usually stored in this field of the advertisement. So our tracker receives this data and this information. It starts processing it according to the configured rules or according to the protocol. So understanding this structure is really, really extremely important. When you are integrating the custom BLE sensors. So what does the payload contain? Inside of the advertisement payload, the information is usually organized into structure. It's called advertisement data elements, or AD elements. So each advertisement data elements, it contains 3 parts. So the first part is going to be the lens, and the second part is going to be the type. The last part is going to be the data. So lens, type, and data. The lens field, it defines how many bytes are included, how many bytes there. The type, it defines what kind of information that are being transmitted. And the last part, which is going to be the type, the data field, it contains the actual sensor information. So different manufacturers structure this information differently. So this is exactly why custom BLE support is very powerful, because it allows you as a user to define how the tracker should interpret this data structure. Once the packet structure is understood, integration becomes much, much easier, much faster, and becomes more flexible at the same time. So in this slide, we will be using the NRF Connect or similar apps that would be allowing to scan the surrounding advertisement packet scan. In the bottom of the slide, you will find 2 QR codes depending on your phone for iOS or for Google for Android. So I advise you to scan one of the relevant QR codes for yourself to download this app. It will become really useful for you when you are going to scan the surrounding environment in order to to get more information about the advertisement packet, as I'm going to explain now. So for practical BLE analysis, we are going to use such tool, which is going to be called, the NRF Connect. It's an app on your phone. The workflow is going to be very simple. First thing, we will have to scan the surrounding environment for the nearby BLE devices. So once you open the app, you start the scan. And then you have to select a beacon or the sensor from the list. You go through the list of the devices or the list of the beacons surrounding you, and then you pick your sensor. Then after that, you analyze the raw advertisement data, which is going to be on the right side of the slide, just giving you an example of how it looks like. So our goal here is that we have to identify and separate the different advertisement data structures inside the packet. So this process that I just mentioned, it helps us to understand how the manufacturer formats their sensor information. How they are like putting their data in order. In real integration projects, this analysis step is often the starting point for creating the custom BLE configuration. So this is the first step in order to create the custom BLE configuration. So what are the typical advertisement advertisement data types? In here, we can see some of the most common advertisement data types that are used in BLE packets. For example, type 0x01, represents usually flags, and type 0x08 represents a shortened local name. Type 09 represents the complete local name, and also 16 represents the service data using 16-bit UUID. Also, the type FF, as mentioned in front of you in the slide, represents the manufacturer-specific data. So in real telematics integrations, the last two types are specifically important because most manufacturers place their actual sensor values in these fields there. So understanding these advertisement data types helps engineers decode the BLE advertisement much more efficiently. So how to get a description of advertisement packets? One of the very common questions, during the BLE integration is, how do we know how to decode the specific sensor, data? So in some cases, manufacturers publish their BLE protocol documentation publicly. So for example, let's take one manufacturer, for example, LA Innovation and also Eurosense. They do that, on their website. They publish their BLE protocol, so you can just go straight to their website and you will be able to download their BLE protocol from there. However, many other manufacturers, they don't do that, and they don't share this information publicly or openly. In such situation, it's usually necessary to request the protocol documentation from them. Maybe you just go to their contact page, see if there is some email, some WhatsApp number. You can just start to write to them, and then you can request this this data, or maybe you can just get it directly from the reseller, local ones, if you have contact. They can also help you to get the protocol from the manufacturer. So once the advertisement packet structure is known to you, once you get the file of the protocol, then the custom BLE feature allows you to configure the decoding process quickly and flexibly. Okay, so let's look at the custom BLE accessories feature. So far, we have discussed the fundamentals of the BLE technology, how the advertisement packets are structured, and why custom BLE support is becoming increasingly important as the BLE sensor ecosystem continues to grow and adoption is really expanding as we speak. So we have also looked at several real-world use cases, and we have learned how to analyze BLE advertisement and also identify the data that we want to extract. So now comes actually the most practical part of today's webinar. Let's see how all of this can be applied in a real integration scenario using the Ruptela's custom BLE accessories feature. So in the next few slides, I will be showing you the complete process from understanding manufacturer's BLE protocol documentation, how you can identify the required data fields, and finally, I mean, you will be able to configure the sensor inside the Ruptela configurator without requiring any dedicated firmware development or maybe even without the need of any engineer's help from our side. By the end of this demonstration, you will be having a clear understanding of how new BLE sensors can be integrated into Ruptela devices quickly and independently. So let's look at the custom BLE accessories feature in action. So now let's look at a practical example of a BLE sensor. In this case, we are going to take the PIR sensor from ALA. It's the presence sensor from ALA Innovation. PIR here, actually it stands for passive infrared sensor. The word passive here, it's a very important thing because the sensor itself does not emit any signal or any radiation. Instead, actually, it simply detects the infrared radiation that already exists naturally in the environment. Every object around us, I mean, emits a certain amount of infrared energy, especially humans and pets or animals, because of the body heat. So that makes them visibly when it comes to infrared. So the PIR sensor here, it continuously measures the ambient infrared energy around it. When a person, let's say, enters the monitored area, the infrared pattern it changes suddenly because the human body temperature is different from the surrounding environment. So the sensor automatically detects this change and then it triggers a movement or a presence event. So it notifies you that someone is nearby. One major advantages of the PIR sensor is that they can work even in a complete darkness. Because they are not depending on the visible light, they use the IR or infrared technology, to detect the surrounding objects. So this makes them very ideal actually for security systems, warehouse monitoring, for example, like also room occupancy detection, for trailer monitoring, and also many other telematics and IoT applications that requires such sensors or such feature. In our case, this sensor broadcasts its information through BLE advertisement packets. Our tracker, Ruptela, listens to those advertisements and can forward the movement events, the sensor states, and other related data directly to the tracking platform. This is a very good example of how Bluetooth Low Energy or BLE accessories can provide you a very useful operational information without requiring complex wiring or additional infrastructure. So on this slide, we can see actual BLE advertisement frame specification for the PIR sensor that we just described. This is extremely important because this document explains exactly how the sensor structure its BLE advertisement data. As you can see on the top, we can see the different advertisement data elements, which we call the AD elements. The table shows both service data format and manufacturer-specific data format. Each row represents a specific byte position inside of the BLE advertisement packet. So it tells you which byte represents what exactly, and the position of this byte in the advertisement packet. So for example, here we can see the lens field, and then we can see also the type field that we spoke about earlier, and then the actual sensor payload information, the most important part of the packet. So the highlighted sections, as you can see them, they are especially important because they contain the PIR sensor data itself. Like for example, the PIR data, you can see the movement state, you can see also events counters, and device identification information. If you look at the bottom of the slide, we can also see some examples of real BLE packets received from the sensor. This is exactly what the tracker receives over Bluetooth. So this is what we are going to receive when the sensor sends for us this data. This raw hexadecimal data may initially look complicated to you, like once you look at it, but once we understand the frame structure, we can begin decoding it step by step. So, for example, our tracker can identify the sensor name, movement detection and state, event counters, and other values directly from a specific byte position. This is where custom BLE functionality becomes extremely powerful. Instead of waiting for predefined firmware support, we can independently define how the tracker should interpret these bytes, from the advertisement packets and positions, and convert them to a useful telemetry data that can be used later on your platform. So this allows you much faster integration of new BLE devices into the telematics system, and this basically makes us to work with basically any type of sensor that exists currently in the market. So now we move from theory into an actual practical integration. As you can see on the left side of the slide, we still have the BLE frame specification or the protocol from the ELA for the PIR sensor. And on the right side now, you can see I have added our Ruptela custom sensor configuration environment. This is where you will be adding your integration, protocol and all the kind of like all the data that you will be needing to enter there. So this idea here, is simple. We take the BLE protocol documentation from the manufacturer, and then we create parsing rules inside of our configurator, Ruptela configurator. So for example, we can define which advertisement data or AD type should be analyzed and which byte offset should be used. Also, how many bytes should be read. You can see also that whether the value should be matched or saved and how the value should be interpreted as well. So in this example, in front of you, that we can see that the first rule used to match a specific sensor identifier, and the second rule is used to save the PIR sensor data itself into an IO element, like to take this value and then to match it to an IO element to send it to the server. We can also configure endineers, multipliers, also constants, and also signed and unsigned integer interpretations. This gives extremely high flexibility, as I mentioned before, when working with different manufacturers and different BLE packet structures. Essentially, the configurator becomes a packet parser that transforms raw BLE data into a meaningful telemetry information. Yeah, now we can see another practical BLE accessory example. We will be talking about another sensor now, like we talked about the PIR sensor earlier. We have here the Eurosense, the DDS PT axle load sensor. This sensor is designed for vehicles with spring suspension systems. This sensor actually very physically mounted on the vehicle chassis, where where mechanical linkage connects it to the axle itself. So as the axle load changes, the suspension movement changes the position of the sensor arm. So internally, the sensor uses a Hall effect, sensor, to measure the angular movement. The measured angle, then it's converted into an axle load information. The sensor broadcasts this information over BLE. This allows the telematics system to monitor vehicle loading conditions wirelessly and in real time. So typical, application for such sensor, they can include overload prevention, also fleet efficiency monitoring, cargo optimizations, and compliance monitoring. However, because every vehicle suspension behaves in a different way, calibration is always required to convert the measured angle into an actual axle weight values in kilogram. So yeah, as we did also with the PR sensor, we're doing here with this sensor. On this slide, we can see that the actual BLE frame structure for the Eurosense DDS sensor. This table describes exactly where each value is located inside of the BLE advertisement packet. For example, we can see the device UID, serial number, message counter, status flags, angle values, weight values. We can see also temperature, battery level, and axle load percentage. This highlighted sections, shows example of a real decoded value. For example, here we can see a weight value of 78 kilograms, temperature value of 24 degrees Celsius, and a battery charge of full battery or 100%. At the bottom of the slide, you can see also there is raw hexadecimal advertisement data from the tracker, that the tracker usually receive. Again, without protocol knowledge, this raw data is not very meaningful. It doesn't make any sense. Only the protocol allows us to understand what's really there. So once we know the byte offsets and the field lenses, we can decode each sensor parameter accurately. This demonstrates why protocol documentation is extremely important for BLE integrations. Finally, on this slide, we can see how the Eurosense BLE data is mapped directly into our Ruptela custom BLE configurator, or the section of custom BLE configuration into our Ruptela configurator. On the left side, we still have the manufacturer protocol specification. And on the right side, we can see the actual configuration rules created inside of the platform. Each rule defines which byte position should be read, also what type of data should be extracted, which I/O element should be stored. Should store the result. So, for example, one rule extracts the beacon state, and another one extracts the sensor values. Another one also extracts the temperature, and another extracts the battery level. We can also define the engineers, the multipliers, the constants, also data sign interpretations. This is the core strength of the custom BLE accessories feature. So I keep repeating this, but this is the core reason why we developed such a feature, that it makes integration very fast and allows you as a user to be basically able to work with any Bluetooth sensor that you basically have locally. So you have more flexibility on pricing, also on the solution that you need to use. So makes you to conquer projects that were not possible before, and to offer your end user kind of like solution that they were not possible from before that. So any Bluetooth sensor you have, now can work with our Ruptela device. Okay, so before we conclude today's webinar, I would like to thank everyone once again for joining us and spending your time with us today. I hope this session has demonstrated not only how the custom BLE accessories feature work, but also the possibilities that it creates for future telematics and projects. As you have seen throughout the webinar, this solution allows customers to integrate new BLE sensors much faster and makes dependency, on firmware development to be really low. You don't need this from us anymore, and it allows you to support again much wider range of accessories, and you can cover many use cases as we speak. So if you have a specific sensor that you would like, for example, to integrate, if you are evaluating a new project, or like if you are simply want to understand whether a particular BLE accessory can work with Ruptela devices, please don't hesitate to contact us, reach us. Our team is always very happy to discuss all your technical requirements, review all your BLE protocols. We can help you with them, assist you with the POC, proof of concept, and help you identify the most suitable Ruptela solution for your project or your deployment. We are here continuously expanding our ecosystem, and we are always interested in hearing about the new use cases and integration opportunities from you as our partners and customers. Um, yeah, this brings us to the last slide. So thank you so much for your attention today and participation. We hope this webinar provided a clearer understanding of how the BLE technology and advertisement structure, how they work, and how they are using custom BLE accessories feature that we released. We are now happy to answer your questions and to discuss the technical details or talk about possible business applications and projects. If you have a question, you can write it on the chat. I can try to go through quickly through the chat and see if some question I can answer really quickly. Others, I promise I will follow up personally to all your question. So don't worry, everything will be answered either now and or later after the webinar. So how many BLE devices can be connected at a time? At the moment, we have 5 BLE sensor can be connected at the same time. Let's pick another question. How to know the zone of this PIR sensor? It's mentioned in their data sheet, I believe. You can download it from there, and you can see how it practically works. Today, we were just covering the use case and how we can integrate such a sensor. Yeah. Regarding the Ruptela, that they need to work with ALA, another manufacturer, to find a way for the sensor to store all the information in its memory whenever it loses the connection with the GPS unit. Actually, we rely on the data that is coming from from the sensor. We keep scanning them. But yeah, it's up to the sensor. If it's dual-way communication, as I said, most of the sensors, as I said in my presentation, they are one-way communication. They usually advertise. But yeah, a good suggestion. We will take it in consideration. Yeah, I see that not much more question that can be answered directly now. I promise you, if I didn't manage to get to your question directly now due to our time limitation with this webinar, I promise you to personally follow up with all your question, or always feel free to reach us directly. If you are quite in rush, but I will be trying to get to each one of you after the webinar. So thank you once again for joining today's webinar. As I said, if you have any additional questions, after the session, please feel free to contact us. We will be also very happy to support you with all your technical consultations, POCs if you have already ongoing ones, and projects planning if you already also, as I said, have anyone that ongoing at the moment. We look forward to working together with you on the future BLE telematics projects. So thank you and have a great day.
Thank you so much, everyone.